All right, so today for Algebra 2, you've got a typed up set of notes there in hopes of helping us get through this a little bit. And I have it on the wrong day or the wrong way. Let's start with example 1. So we're looking at solving problems with systems today that are going to deal with mixture, motion, and digit problems. I don't think we've done any digit problems yet, so we'll look at those too. Always read, plan, solve, and check, okay, to get an idea of what's going on in your problem. So let's look at example 1. We're really just working through these today. So it says find two numbers whose, so let's try again, find two numbers whose sum is 23. So sum is addition. And whose difference, that's subtraction, is negative 81. So two numbers. Doesn't matter what numbers. So we're just going to use x and y for our two numbers. But when I add them, so x plus y means equals 23. And we know the difference. So x minus y is equals negative 81. So these are my two equations in the system. Okay, those are my two equations. But I can put them in a system and I can solve them. So if I would bring them together, like if I bring this one here, x minus y equals negative 81, we would see that our y's would cancel. So our y's cancel, and we're left with 2x equals 23 minus 81, which is negative 58. I can divide by 2 and get that x equals negative 29. And now I can sub that in for the other equation. So let's sub it into this one because it's handy. So x is negative 29 minus y equals negative 81. So let's add 29. Then we have negative y equals negative 81 plus 29. Oh, wait, hold on. Yeah. That's just not how I did it in my notes. I did it differently today. So go me. So negative 81 plus 29 is, let's do a little bit of math here. I'm going to go ahead and subtract those to get my difference. 7 minus 2. So I should have negative 52, I believe. Yes, okay, perfect. And let's divide by negative 1 to get a positive y. So y equals a positive 52. So my solution, right, is always an ordered pair. So my solution, well, in this case, it is a system, but the two numbers are negative 29 and 52. If I was writing it as a solution to a system, it would have to be negative 29, comma, 52, because the solution is always written as an ordered pair. Okay, perfect. Now, let's look at example 2. Let me move some work up here. So we'll let you get that copy down if you need to pause, and I'll clear it off then. Example 2. Mr. Perry has invested a total of $10,000 in two stocks. Okay, I'm right, in total. And it's invested, that's important. That's his principal, right? We're using this formula of principal times rate times time equals the interest, or you might have seen it as I equals PRT in the past. Okay, so AmeriCorps returned 8%, while BankCorp returned 10%. So that's the rate. How much did he invest in each stock if his total return last year was $850? Is his total return. So we need to put this information into that table to help us where they belong. Now the cool thing about, now that we know how to use systems, okay, is that we don't have to stay with one variable like we did earlier in the year when we were trying to solve these. We can actually use two variables now because we know how to deal with them. Okay, so let's see. He invested a total of $10,000 in two stocks. Well, we don't know how much he invested in each one, what principal. So one could be X and one can be Y. But we do know that total it's 10,000. So I'm going to put that down there. Total it's 10,000. Okay, so we've got that kind of taken care of. The rate, our 8% here is a rate, and our 10%. So AmeriCorps was 8%. We always have to write that as a decimal, so 0.08. And Bancorp was 10%, so it's going to be 0.10. Okay, so we've got those in our chart. How much did he invest in each stock if his total return last year was 850? Now, this is important. It doesn't seem like maybe. His total return last year, so that answers the question of time. His time was 1 year for both of them. Okay. And so we don't know what his interest for each one was. So it's kind of like it was with the total of $10,000, but we do know that it was 850. So I'm just going to write 850 down here because that was the total interest. All right. So our interest column is blank. But to find it, we're going to take our principal times the rate times the time to get our interest. So this is going to be X times 0.08 times 1. So 0.08x is that one. And if we multiply these all together, like the formula says, we're going to get 0.10y. You don't have to write that 0 there, but it is, I find it handy to remember it's 10%. Okay. So now we have to, I'm going to write the word total here. These are our totals for those categories. All right, so now I've got it in my chart, but what does it mean? Like, how can I make this into two equations? Because I want to make a system. So Mr. Perry has invested a total of $10,000 in 2 stocks. Well, that's kind of handy that we've got this set up here. So if we add these together, the principal that we invested in AmeriCorps and Bancorp, it's going to give us the total. So my formula for this one, I need to change colors, that yellow is terrible, is X plus Y equals 10,000. So I wrote that 10,000 down there to help me remember, but it's an addition problem. That gives me one of my equations to a system. So where do you think my other equation might come from? Absolutely, it's going to come from this interest column. Okay, so if we are combined interest, so 0.08x plus 0.10y equals 850. There are my 2 equations in the system. All right, so then to solve, what could we multiply? We're going to have to use substitution or elimination on this one. Substitution would work really well with these two. So it doesn't really matter how you want to do it. But if we want to change this to be like y equals negative x plus 10,000, right? Because we subtracted x from both sides. That would be fine. And then we could sub it into this equation. So then we'd have 0.08x plus 0.10 times y, so times negative x plus 10,000 equals 850. Again, I don't know why I keep doing things differently on the board than I actually do in my notes. I think it's because I don't like the way the book has me do them. But anyway, so that would give us 0.08x plus, actually I'm going to change that, well, plus a negative 0.10x because I'm distributing. And then I need to distribute again. So 10,000 times 0.0 or 0.1 equals, so plus 1,000 equals 850. All right, then I can combine like terms, right? So these are my like terms here. So it's going to give me negative 0.02 x plus 1,000 equals 850. Subtract 1,000. So negative 0.02x equals negative 150. All right, divide by negative 0.02. And we're going to get x equals, I'm doing some math. Yep, just to make sure that it matches my other work and I didn't make a mistake, equals 7,500. So we use substitution that time. And now we can sub that one into one of the other ones, okay, to get x, so, or to get y. So let's put it into this first one. Or you could put it into this one. Doesn't really matter. So y equals negative 7,500 plus 10,000. So y equals positive 2,500. Okay, because we subbed it in again. All right, so for the rest of these, we're going to work on the setup. Okay, I'm going to show you the setup, and then you're going to have to go back and solve, because taking the time to solve it is kind of a waste of your time. It's the setting up of the equation and using the chart that's going to be most beneficial for you to see and for us to talk through. So, kind of like yesterday, you can solve the problem and I'll give you the answer to make sure you have it correct. All right, example 3. 2 buses, 412 miles apart, head toward each other. So let's see. We got 2 buses, 412 miles apart, head toward each other. One travels 3 miles per hour slower than the other. They meet in 4 hours. What is the average speed of each bus? So, okay, so we know they're 412 miles apart. They're headed towards each other. Okay, to meet, one is 3 miles slower than the other. Okay. So the cool thing again though is because we're working with systems, we can use 2 different variables. So we have a slow train. We don't know its rate. It's just the slow train. And we have a fast train. There we go. Okay. The time is 4 hours, right? It's right here. And then our distance is an equation. Rate times time equals the distance. So the distance for the slow train is 4s, and the distance for the fast train is 4f. And we know they went 412 miles total. Okay. So how can we get 2 equations out of this? Well, one is this one right here, right? 4s, the distance that the slow train traveled, plus the distance, 4f, that the fast train traveled, has to equal 412 miles. The other formula is a little bit harder to see because it's not in the table. It's this fact that one train travels 3 miles slower than the other. So, because we do have to have another way to link S and F together. Okay, so typically, like in the past when we've done these, we've had to use the same variable. We don't anymore, but we have to know that the fast train is going 3 miles faster than the slow train. So we have F equals 3 plus S. All right, so in this case, it's a perfect setup for substitution for you to solve. But now you have your 2, these are your 2 equations of the system. Okay, and so when you solve them, because I'm going to set up the system and you can solve. When you solve, you're going to get S equals 50, and you should get F equals 53. When you solve them, those should be your solutions. All right, and then we're going to move on to the next one. So I want you to go back and solve that when you have time after we're done. So flip over to the back. All right, example 4. During the rainy season on the Amazon, Pastor Sosa can travel 60 kilometers downstream in the same time. Let's see, hold on, 60 kilometers downstream in the same time that it takes to travel 36 kilometers upstream. If his boat can travel 16 kilometers per hour in still water, what's the average speed of the current on this stretch of the river during the rainy season? Okay, this one's a little tougher to look at. So let's read it again. During a rainy season on the Amazon, so we're talking the Amazon River, Pastor Sosa can travel 60 kilometers downstream. Okay, so that's his distance, right? Kilometers. So we're going to put 60 kilometers downstream in the same time that it takes to travel 36 kilometers upstream. So we're going to put that in there. If his boat can travel 16 kilometers in still water, or 16 kilometers per hour in still water, what is the average speed of the current on this stretch of the river during the rainy season? Okay, so this is implying that there is a current, right? It's implying that there's a current that's going to speed him up or slow him down. Well, if he's, because we know his rate is here. If he's going downstream, his rate is going to be 16 miles per hour or kilometers per hour. And then is the current going to speed him up or slow him down? Hopefully you said speed him up. So this would be 16 plus the current. Okay, however fast the current is going. So if he's going upstream, right, he's rowing against the current, his speed is 16 minus the speed of the current, whatever the current is. If it's 2 or if it's 7, we don't know. Okay. So hopefully that kind of makes sense because this is the hardest part. The rate, I feel like, is the hardest part of this problem. Okay, and then our time. We don't know how much time it is, but we know that it's the same time. So we can just put t in there. The nice thing about this one is that we have our two systems right here because it's our rate times the time equals the distance, and our rate times time equals the distance. So my two equations for my system are simply the quantity 16 plus c times t equals 60. And the quantity 16 minus c times t for time equals 36. And so we'd have to distribute. Okay, so this would be 16t plus ct equals 60. And this equation would be, again, we're distributing, 16t minus ct equals 36. These equations are set up to be solved already by elimination, right? A positive ct is going to be eliminated with a negative ct. Okay, so you can do elimination from there and solve. And you should get t equals 3 and c equals 4 when you solve this system, okay, to know that it's right. But it is handy that in this case, we already have two variables in there, so we already have our systems of the equation. Okay. Now we're going to start into some new territory. We have not done any digit problems. So there's a little bit of a note here. And that's all the book offered. So when solving problems that refer to the digits of a number, okay, each digit is determined by place value. So T is going to represent the tens digit, and U represents the units digit, or the ones, okay, place value. A 2-digit number would be 10 times t, because it's in the tens place, plus u. Okay, so we're going to look at this because that seems a little wonky, right? But if we just want the digits, we're going to just use t and u. If we want the number itself, we would use the 10t. So let's look at that in example 5. I think it'll help. So it says the sum of the digits of a 2-digit number is 11. So we only care about the digits, you know, what they are. So sum is addition of the digits of a 2-digit number. So we're going to say x and y is 11. So we're going to say x plus y equals 11. Okay, because we're just adding the digits together. We don't care. So let's say the number is 26. Okay, so x equals 2, y equals 6. This would equal, the sum of these would be 8. Okay, but if we were to actually write the number, we would have to say, well, it's 2, and I need to use t and u, not x and y. Okay, so it would be 2x, yikes. So to get the actual value of the number, we would say 10x plus y, because 10 times 2 plus 6 equals 26. And that might have been more confusing to you. Hopefully it wasn't, but I also need to fix my mistake here because I told you we're going to use t and u, and you will always use t and u. So I don't know why I did what I did, but I can fix it. So we're going to have t and u. So the tens digit plus the ones digit or the unit digit equals 11. All right, so let's try the next one. The difference, that's subtraction, of the number. Ooh, this time it's the number. It's not the digits, but it's the number. And a number obtained by reversing the digits is 45. What is the original number? Okay. So this time we're looking, so this one, the first one in red, asks for the sum of the digits. This one is saying the difference of the number. So the number is 10 times t plus u. That's the number. So it's the difference of the number, so now it's subtraction, and a number obtained by reversing the digits. Well, if we reverse the digits, it's going to be 10 times u plus t. Because I reversed the u and the t here. Because the number is 10 times t plus the units. Now I'm doing 10 times the unit number plus t. So again, if this was 26 earlier, right, this would have been, the 2 would have been our t, and this would have been our u. If we reverse those digits, we would have ended up with 62. Okay, if we reverse the numbers. That's all it's getting, but we're using the formula to do it. Okay, so there is part of it, the beginning of it. The reversal is means equals, so equals 45. So those are our two equations. The blue one here, we can simplify that. Okay, remember this minus sign needs to be distributed to each part. So let's simplify this a little bit. So we've got 10t plus u minus 10u minus t equals 45. So if we distribute 10t minus t, okay, is 9t, and positive u minus 10u is going to give me minus 9u equals 45. So you can use substitution or elimination, but those are your two equations to use in your system. Okay, so you can use either method to solve those, and when you solve them, you should get that t equals 8 and u equals 3 for that. And let's try the last one. The sum of the digits, okay, so the sum of the digits, we've got digits there, of a 2-digit number is 12. So t plus u equals 12. Again, is equals, sum means plus. When the digits are reversed, okay, so the digits are reversed, the new number is 18 less than the original number. What is the original number? Okay, so again, now we're talking in the blue, we're talking about numbers. Okay, so the first one was only talking about the digits. This one says when the digits are reversed, the new number. So that means we're going to have 10t plus u. That's the number. Okay, is 10t plus u. Is 18 less? Hold on though. This is the actual number. In this case, right, the digits are reversed, so I need to reverse those digits. So it's going to be 10u plus t. Is 18 less, less means subtraction, than the original number. So the original number is that 10t plus u. So this equation is 10 10u, that quantity 10u plus t is, because it's so equals, 18 less. Well, that's minus, so I'm going to put my 18 here. 18 less is we're subtracting 18 than the original number. The original number is 10t plus u. Okay, so again, we don't, on this one, we don't really have to have those parentheses. So you could get rid of them and go ahead and work it out. Okay, so to work it out, we need to get our like terms probably on the same side. So if we subtract 10t here from both sides, and we could subtract, so then we'd have 10u minus 9t equals u minus 18. We could subtract u, so then we would have 9u minus 9t equals negative 18. Okay, so there's one of your equations in your system. Your other equation, a little more simplified. So you can use, again, substitution, because you have a t and a u that you could isolate, or you could use elimination, multiply them by 9, and eliminate 1 and solve. Doesn't matter which one you choose to do, but you should get, when you check your work, t equals 7 and u equals 5 to give you the number of 75. Okay, so hopefully that helps you work through some of these problems. Again, I understand that setting up the table and setting up the system is the hardest part there. All right, so then for your homework is page 120. Yeah, page 120. I was right. All right, so homework is going to be page 120, and I want you to do numbers 1 through 15, odd, so you don't have too many problems, and then I want you to do 26 through 28, all. So I know there's a couple even in there, you can't check your work, but page 120, numbers 1 through 15, odd, 26 through 28, all, to solve for those. So some of them you might need a table, and some of them you're just writing the equation. Okay, but again, it's 1 through 15 odd, so there's like less than 15 problems there altogether today, maybe less than 10 even. So make sure you've got those done for me tomorrow, and I'll see you then.